Hello everyone, today we're talking about addition and subtraction formulas. Section 7.2 you will notice in our book. We're only going to cover section 7.2, 7.3, and 7.4. That's all we're worried about getting through. So don't be alarmed that it's starting off at 7.2. We're only going to cover 3 sections in chapter 7, starting at 7.2. So 7.2 are addition and subtraction formulas. If this is blurry, again, the chart is in the PowerPoint, so you can just go ahead and PowerPoint, see nice, clear. Basically, it's just giving us our formulas for sine. If we have sine addition, then we do sine s cosine t plus cosine s sine t, whatever our values for s and t may be. Cosine, if it's a plus, it's a minus. That's how I remember it like that. And then tangent, if it's a plus, we have a plus on the top, minus on the bottom. Tangent with a minus, minus on the top, plus on the bottom. And you'll see, I'm not even going to ask you to memorize these, so as long as you can work these, you'll be all set for chapter 7. So, find the exact value of the expression. You'll notice they want the exact value. And a couple of you even asked me, well, what happens if we have like an angle that's not 30, 45, 60, or 90? You know, one of those that fell perfectly. Well, we're going to need to use the addition or subtraction equations for sine and cosine. So, to get to 75 degrees using the angles that we know, that's going to be cosine of 45 degrees plus 30 degrees, right? 45 plus 30 is going to give me 75 degrees, so cosine of 75 degrees. Then I just plug into the cosine addition formula. So that's cosine 45 times cosine of 30 minus sine 45 times sine of 30. Right, so I'm just multiplying these, and then subtracting those products. So cosine of 45 we know is radical 2 over 2. Cosine of 30 we know to be radical 3 over 2. Minus sine of 45 is radical 2 over 2. And sine of 30 is 1/2. So we go ahead and simplify. We get radical 6 over 4. I can multiply. When I'm multiplying radicals, I can multiply the numbers underneath the radicals, keep it under the radical, minus radical 2 over 4. So I can simplify this a little bit further. When I'm adding or subtracting, I have to treat these like these are different variables. So I can't combine the radical 6 and the radical 2. So my eventual answer ends up being radical 6 minus radical 2 over 4. And that is the exact value for cosine of 75 degrees. Then I'm going to go ahead and do the same thing for cosine of pi over 12. Okay, so I want to find the cosine of pi over 12. To get there, I came up with cosine of pi over 4 minus pi over 6. Now, how I came to that? I know I have to have a denominator of 12 and a difference of 1 pi over 12. So I came up with pi over 4 minus pi over 6. If I have a denominator of 12, that means I get 3 pi over 12 minus 2 pi over 12. Right? If I take 4, multiply it by 3, that's how I get to 12, so I got to do the same to the numerator. And if I take a 6, multiply it by 2, that's how I get to 12, multiply the same thing by the numerator. So you can see if I have a 3 pi over 12 minus a 2 pi over 12, that gives me pi over 12. So we have cosine of pi over 4, cosine of pi over 6, which we know those values. So you have to manipulate cosine of pi over 6, cosine of pi over 4, or cosine of pi over 3 to get to the value that you want. So here I manipulated these two values to get to pi over 12, and then I go ahead and use the cosine formula again. So I get cosine pi over 4, cosine pi over 6, minus, since this is a minus, this is a plus, sine pi over 4, and sine pi over 6. So I'm not asking you to memorize this, like I said. As long as you can use the addition and subtraction formulas, you're all set. So cosine of pi over 4 is radical 2 over 2. Cosine of pi over 6 should be radical 3 over 2. Sine of pi over 4 is radical 2 over 2. And sine of pi over 6 is 1/2. So this gives us radical 6 over 4 plus radical 2 over 4. Now since we're adding, we still can't combine the radical 6 and the radical 2. So I end up with radical 6 plus radical 2 over 4. And that is the exact value for cosine of pi over 12. Next, find the exact value of cosine of 11 pi over 12. So to get to 11 pi over 12, I added. So I took cosine of pi over 4 plus 2 pi over 3. Right? We know the exact value of cosine of 2 pi over 3 because that's just going to have a reference angle of pi over 3, and we know cosine of pi over 3. Now how I got to this real quick, pi over 4 plus 2 pi over 3. Well, to get from 4 to 12, I multiply by 3, so that gives me 3 pi over 12. Plus, to get from 3 to 12, I multiply by 4, that gives me 8 pi over 12, which gives me my 11 pi over 12, which is what I was looking for in my problem. So now I go ahead, use the cosine formula again. So cosine of pi over 4, cosine of 2 pi over 3. Since this is a plus, this is a minus. Sine pi over 4, sine 2 pi over 3. And I should know these values. This is radical 2 over 2. Cosine of pi over 3 should be 1/2. And let's see, since cosine 2 pi over 3, since that's in the second quadrant, that should be a negative 1/2. And then subtract, sine is going to be radical 2 over 2. Sine of 2 pi over 3, since that's in the second quadrant, my y values are positive, so that's going to stay positive radical 3 over 2. Go ahead and simplify a little bit more. I get negative radical 2 over 4 minus radical 6 over 4. So my final answer being negative radical 2 minus radical 6 over 4. And that is the exact value for cosine of 11 pi over 12. Finally, we're going to use the addition or subtraction formula to take and write this into one single value, then find its exact value. So, since here I have cosine, cosine, minus sine and sine, that means I must have started with an addition, right? I must have started with a cosine of s plus t. So, you can see here I have two cosine values minus two sine values. That's the same as what I had at the end there. So, I want to combine this into a cosine of 13 pi over 15 plus negative pi over 5. And finally, when I have cosine of 13 pi over 15 plus negative pi over 5, I'm going to want to get a common denominator. So that's going to give me cosine of 13 pi over 15 plus a negative 3 pi over 15, right? 5 to get to 15. I just multiplied by 3, so I multiplied the numerator by 3. And if I keep on going, that gives me cosine of 10 pi over 15, which reduces down to cosine, if I divide them both by 5, 2 pi over 3. And we should know that since that's in the, right, 2 pi over 3, that's going to be in the second quadrant with a reference angle of pi over 3. So since we have a reference angle of pi over 3, that means cosine is 1/2, and in the second quadrant, cosines, right, that should be pi over 3, and yes, it's taller than it is. So cosine would be negative 1/2. Okay, so you should be able to use your addition and subtraction formulas to work backwards, just like you did in the beginning, to end up breaking them up and solving for exact values. So go ahead, try the examples I gave you in the PowerPoint. You'll notice there are answers at the end of the PowerPoint, so you can check your answers. And then there are practice problems in the PowerPoint that will be due when we get back. So if you have any questions, you can hit me up on Piazza, and I can answer them over break or over the weekend.